Yeah, hi friends. Welcome to TMRM Art YouTube channel. So today we are going to see uh, the newly added gate topic. Okay, that is correlation and regression analysis. Okay, in the mathematics section. So we'll get some idea on that. So correlation means measures. So it measures the relationship between the two variables. Okay, and regression predicts the value of one variable from the other. Okay, correlation measures the relationship between the two variables, and regression, it can predict the value of one variable from the other variable. Now here x is in hour and y is in marks. So x is the study hour given. This is 1, 2, 3, 4, 5 in hour, and here the marks are given 20, 30, 30, 40, 50, 60. Okay, as x increases, y also increases, so they move together. Okay, so they move together. Now types of correlations. So positive correlations is here r greater than 0. R is the correlation coefficient. Okay, so here you can see the y-axis and x-axis. If x increases here, y also increasing. Okay, if x increases, y also here increasing. Now negative correlation, here r less than 0. Okay, so if x increasing, y here also decreasing. Okay, no correlation means there is no clear pattern is there. So every time if r equal to 0, that does not mean there is no relation, but there is no linear relations, we can tell. There is no linear relation. Okay, and correlation coefficient are always exist in between -1 to +1. Okay, and r equal to +1 means the perfect positive correlation, and r from 0 to +1, then in that range, if it is there, then it is positive correlation. Okay, strength increases as r tends to +1, and r equal to 0, no linear correlation. Okay, and -1 to 0, if r is from -1 to 0, then negative correlations. Okay, strength increases as r tends to -1. Strength increases here means in these cases, if x increases, then y also significantly decrease. Okay, that's why it is told that strength also increases here. Okay, for positive correlation also is told that strength is increased if r is greater than, means r tends to +1. So r tends to +1 means um, so the slope will be like that. So r if it is less than +1, that means that time it will be like that. This time as r increases, the slope also increases. Okay, so that means r y will change faster with change of x when r increases. Okay, now important concept here, like correlation measures association, not the causation. Correlation is the measurement of the association only. Like these are seen in the experimental data, not like if hour is less, then marks will be less. Like there can be an intelligent guy, student who can just study 1 hour and get even more than 60 marks. That is also possible. So correlation measures the association, just the observation, not the causation. Okay? So r equal to 0 does not necessarily mean independence. R equal to 0 does not necessarily mean independence here. There might be some nonlinear relation. Okay, changing scale or origin of the variable does not change the value of R. Okay, if we change the scale or origin of the variable, that does not change the value of R. Okay, it will, if you change the origin or scale also, then it will not change the value of R. So R is unit free. Now R remains the same if x equal to y are interchanged. Now correlation shows direction and strain. Correlation shows the direction and strain, and regression is used for prediction. Okay. Regression is used for just prediction, and correlation shows the direction and strain. And R remains the same if x and y are interchanged. So R is unit free. Now regression analysis. Regression line of y on x has the form like that. So y here, then a plus bx used to predict y from x. Used to predict y from given x. So this is y-axis, then this is x-axis. Okay. Now here's the plot is like that. So this is the intercept, that is a, and so a is the known value, and we need to predict the y. B is the slope, the regression coefficient of y on x when we are finding y and x is known. Now it is denoted by byx. So relationship between the regression coefficients and correlation is b of yx into b of xy equal to r square. So product of two regression coefficients equals square of correlation coefficient. Okay. So this is correlation coefficient and these are the regression coefficient. Okay, this is the relation. Now properties of regression coefficient. Both regression coefficients have the same sign as R. R is the geometric mean of these two. Okay, R is the geometric mean of these two. Here from here we can tell. Okay, R is geometric mean of P of yx and B of xy. If mod of R equal to 1, both regression coefficients are finite and non-zero. So if R equal to 1, then they should be finite and non-zero. If R equal to 0, so at least one of the regression coefficient should be 0. Now example of regression prediction. Okay, so regression equation y cap equal to 20 plus 5x. Okay, if student studies 7 hours, so what marks can be predicted? So just place 7 in place of x. Okay, because x is the hour and y is the marks. Okay, so here it is, they should mention that before. So now put x equal to 7. So just putting, we are getting 55. That is the prediction actually. So that is the example of regression because we are predicting here. Now guest style questions, MCQ. Okay, the correlation coefficient between x and y is 0.8. So if x increases, what can we say about x? So correlation coefficient here 0.8, that means positive correlation. So if x increases, then y also should increase. That means this one, okay, y tends to increase. So C is not there. Okay, so B is the right answer. Now here, if the correlation coefficient between two variables is -1, which statement is true? Okay, the correlation coefficient between two variables is -1, then which statement is true? So here we have studied here. Then it is perfect negative correlation. So perfect negative linear relationship. Okay. Correlation coefficient normally used for the linear relationship, as it is -1, so perfect negative linear relationship. So here we have seen already the negative linear relationship. So this is perfect one. Okay. Now the next question is, just a second. Testing. Now question number 3. Which of the following cannot be the value of correlation coefficient? So correlation coefficient range is from -1 to +1. So this is exceeding the 1. So this cannot be the correlation coefficient value. Now question number 4. The regression equation y equal to this one. So what will be the value of y when x equal to it? Just simply put the value. So you will get the answer here 44. Now question number 5. If correlation coefficient r equal to 0, can we conclude that x and y are independent? So if r equal to 0, can we conclude that x and y are independent? So that not necessarily true. Okay, so the right answer is no, because if r equal to 0, that means no linear relationship, but not linear relationship may exist. Okay, this is not linear, but that is also a relationship. So also variables may not be independent. Okay, also the variable may not be independent. Okay, they can be dependent with some complex relation. So this is not true. Like if r equal to 0, that does not mean that they are independent. They may depend on each other. So question number 6, the correlation coefficient between x and y is this one. So which statement is correct? So this is strong negative, because this is very near to -1. Now question number 7, if height and weight of persons have correlation r equal to 0.85, okay, can we conclude that increasing height causes weight to increase? Height and weight, there is no like linear, I mean, you cannot say height equal to weight. Okay, but as per data, if you analyze and see, like if height is more and weight is more also, that time, that then there you can say that yeah, the correlation association is there, but that does not mean that the height equal to weight. So correlation shows association, not cause and effect. So here option B, like can we conclude that increasing height causes weight to increase? That we cannot conclude from here. Which can just observe the data and predict with help of regression. So now the next question is, if correlation coefficient between x and y is 1 and every value of x is multiplied by 10, then what will be the new correlation coefficient? Yeah, if then x is multiplied, every x value is multiplied by 10, that means it is the scaling operation we are doing, but at that time also that correlation coefficient will remain same. We have already seen here. Okay, they are changing scale or origin of variable does not change the value of r. R is the correlation coefficient. Okay, now so correlation coefficient is unit free and scaling does not change r. Now the next question is, the regression equation y equal to 3x plus 5. So what is the predicted value of y when x equal to -2? So if we put x equal to -2, then we will get the value of y is -1. Okay, that is the answer. Now the last question is, for two variable b yx equal to 2 and bxy equal to this one. So what is the value of correlation coefficient R? Okay, we have seen already the relationship between the regression coefficient and the correlation coefficient. So these regression coefficient values are given. So correlation coefficient value R will be plus minus 0.5. Sign cannot be determined from the given data. So option C is the right answer. Hope something cleared here. So if you enjoyed, or like if you have some suggestion, please comment it out, and please like and share. Thank you. Thank you for watching the video. Jai Hind.